quickly revisit Newton's law of cooling. Okay, so here goes the formula. It looks like this. The temperature with respect to time, is equal to the temperature of the environment plus the initial temperature minus the temperature of the environment times e to the negative kt. Okay, and that should look familiar because we've already done a homework problem where we had to use this formula to set it up. So this represents the temperature with respect to time, or temperature after a given time. This is the temperature of the environment. Some people call that temperature of the medium. This is the initial temperature. K is our constant, T is our time.
Now, inside the parentheses, is the E like EE or environment?
Environment.
And beside the first temperature of the environment, is that a plus?
That's a T. That's a beautiful cursive T.
Wait, no, the other one. To the right of it. Okay, equals T.
Okay, that's a plus.
I don't like T's. Yeah, me neither. I hate them.
Maybe you should use
really
like
curly at the end.
And L's. Because I just do them straight.
Okay, well that's dumb. You should do
Okay.
Dumb.
Well, I mean, she's saying I can't recognize.
All right, so here's our situation.
I did say I couldn't recognize it. We would make stuff up because you have no work.
All right, our situation is this. We have a hard-boiled egg.
Is this being recorded?
Okay? And the hard-boiled egg is currently 96 degrees Celsius. It's pretty warm, right? Okay, and then we're going to place that into water to cool. And the water, I'm trying really hard to say it correctly. The water
There you go.
is 16 degrees Celsius. Now, we're going to wait 4 minutes. So 4 minutes later.
Will we ever get like Fahrenheit and Celsius combos and have to convert them?
No.
Alright, because I really am not a fan of conversions.
We measure the temperature of the egg, and the egg is now cooled off to 45 degrees Celsius. So, when will the egg reach 20 degrees Celsius? And actually, is 20 degrees Celsius a possibility? Yeah, because the water it's setting in is 16. So we actually could cool down to 20. All right, so there's our situation, and let's work through it mathematically now. So our the hard-boiled egg, 96 degrees Celsius. What would the 96 represent in this formula? Okay, so that's our T naught, isn't it? Okay. What about the 16 degrees? What does it represent in this formula? TE.
Wait, what?
T.
Oh, okay.
TE.
It's just T.
Alright, let's calm down.
Okay. What about the 4 minutes later? What does that represent? The 4 minutes later, this represents T. And the 45 represents T of T. That's the temperature after a given time. Okay, so now let's plug in what we just identified. So we have 45 equals 16 plus 90 minus 16. Excuse me. 96 is correct. Minus 16 e to the negative k times 4.
Okay, so
now we have to solve for k. You are correct. We solve for k. So what do we do first?
What
What is K exactly?
K is our constant.
60, no, minus 45.
Okay, so 45 minus 16 is 29. Now what do we do?
Take the natural.
Divide by 80.
Divide by 80.
Wait, what do we do right there? Oh, we subtract the 16.
And then take the
Natural log of both sides.
Now we take the natural log of both sides.
And then you do the thing.
Okay, now this comes out in front. And natural log of E does what? It's 1. Divide by negative 4. So the exact value for K is natural log of 29/80 divided by negative 4. Now, we could find the approximate value of that, but when we're using our calculator to answer the last part of this, if we have come up with a decimal approximation for this, which would be, you guys tell me.
Number.
Can we give them a yawn?
I got 0.25.
You don't have to like get into it.
36 or 37. Just round it.
Miss Willoughby, what did you do with the ln there, the natural log?
I took the natural log of both sides, and I chose natural log because I saw the base E.
Yes, ma'am.
So we take the natural log of both sides, and then this can come out in front and become multiplication. So it's negative 4 times the natural log of E, and the natural log of E is just 1. So that goes away.
Okay.
And then we have to, this doesn't go away, so we have to leave it. And then divide by negative 4 to solve for
So
K.
when you took the natural log, it made the negative 4K like not an exponent anymore?
Correct.
Okay. And then,
We can write it as a product. This power can come out and become a product. That was one of our
okay.
rules for logarithms.
Alright.
Okay, so now this is what we found for K. But when I plug it back in, I'm going to plug back in the exact value right here, because then that gives me less room for error. Now, the final question is, when will the egg reach 20 degrees Celsius? So we would say 20 is equal to 16
Plus 80E.
plus 80E. That's not 80. 80E.
And then the K.
Okay, so this is negative, and it's negative K, so a negative and a negative makes a positive. So I can just do the ln of 29/80 over 4. And it always opens it on your calculator, so you'll have to close it. Times t. So now we solved this one. So we move the 16 over. Divide by 80. What do we do? Natural log. Okay, so when I take the natural log here, I'm going to get the natural log of E to the ln of 29/80 over 4 times t. Well, this can come out in front, can't it? So I'm going to make it. Can use that property to pull this out. Well, I'll get it in just a second. It comes out in front. And then what is the natural log of E? 1. Chimneys. There we go. So we do the natural log of 1/20th divided by, big set of parentheses here, guys, ln of 29/80ths divided by 4. That's exact. And so this is about how many minutes later?
About 12. That's 11.
11.81? Yeah? Good. Okay. Now, you're going to use Newton's Law of Cooling today on an activity we do after you do your group activity. We have 2 things we're going to work on today. The first thing is the drug concentration worksheet. So all of you that are all for the large group performance thingy today, you're going to first do the drug concentration worksheet. And that's to be turned in. And you may work in groups of 2 to 3. And then after that, you're going to do the cooling corpse lab. This is where you determine who killed. Let's see who gets to die this time.
Ryan.
No, we're not picking one of our friends.
Can we do it?
Oh my.
Oh.
Oh, Dr. Deadman is murdered. Okay, so on the cooling corpse lab, you're going to determine who killed Dr. Deadman. And tomorrow, I'd like you to have parts 1 and 2 done. Now, tonight, if this troubles you, I want you to put a good effort into it, but don't spend more than like 15 to 20 minutes.
30.
Stop. Stop at that, and then tomorrow, we'll group back up. You can share with your group how far you got, if you ran into a wall, what bothered you there, and maybe together as a group tomorrow, we'll get through this parts 1 and 2. Okay? All right, let me go ahead. You may divide up into groups of 2 or 3, but everybody gets one. Okay.